Ah, sige wait lang. Wait lang, tinatapos ko lang 'to. Ah, bakit po hindi mo naman pala inayos, eh.
Ano yun, man? Ano yan? Ay, yung ano yan, yung mga...
Ito, bakit po? Bigay mo nga dun, ha?
Kailangan tayo. Ito yung ano, yung dineliver ngayon. Yung Uniqlo.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem binary search. We're given an array of integers nums, which are going to be sorted in ascending order, and we're also given a target integer that we're going to look for. If the target exists in the array, then we can return the index of it. If it does not exist, then we return 1. The goal is to create an efficient algorithm that can run in log n time. So what algorithm are we going to use? Well, the problem pretty much tells you binary search. So while this is self-explanatory and a pretty basic algorithm, I still think it's really important because a lot of problems kind of extend the idea of binary search and then make it even harder. And this is actually a pretty common interview question, to be asked some variation of binary search. So this is a very good problem to practice, and your goal should be able to implement binary search very quickly, basically as if you were doing it in your sleep. So I'll try to explain this quickly, but also in a beginner-friendly way. So the input array is sorted. The target value could exist anywhere in this array, or it might not exist at all. When we start, we are considering the entire input array. How are we going to do that? Well, we're going to have 2 pointers. One pointer is going to be at the leftmost index, which is initially index 0. Another pointer is going to be at the rightmost index. These pointers mean that we are considering the entire range. Now, if we could only look at one of these values, which one should we look at? Should we look at the leftmost? If we do that and we see that it's not equal to the target, then we've only eliminated one possibility and we still have to search all of these. If we look at the rightmost, similarly, it's not the target, so we've only eliminated one possibility. We still have to look at the rest of them. But if we look at the midway point, and technically either of these could be the midway point, the way we calculate it, though, is going to be literally taking the left and right indexes and dividing them by 2, which I think will lead us to this position. But approximately the halfway point. Why should we look here? Well, we can compare it to the target. It's not equal to the target. So what does that tell us? Have we only eliminated one possibility? No, because remember, the input array is sorted. So if this is not equal to the target, we should also ask, is it smaller than the target or is it larger than the target? In this case, it's smaller than the target. So if this is smaller than the target, then everything to the left of it is also going to be smaller than the target. So this was our midway point, we'll call it M, and we found that it's smaller than the target, so we can eliminate these 3 values from consideration, everything over here. How are we going to, represent that in code? Well, we're going to take this left pointer and then shift it to be M plus 1. So now our left pointer is going to be over here. This represents possible range of solutions is going to lie within, these 2 pointers. So at this point, we're just going to repeat the algorithm, repeat what I pretty much just did. Now, if we take these 2, add them together, divide by 2, the middle is going to be over here. So then we're going to check, is this equal to the target that we're looking for? In this case, yes, it is. So now we can return the index because that's what we were trying to do. We can return M, whatever it happened to be. I think it's 4 in this case. So that is pretty much the idea of binary search. Okay, so now the time complexity. If you know binary search, you already know that it runs in log n time, but let's quickly understand why. So we're not considering this example anymore, but suppose we had 16 values in the input array. Every time we go to the midway point, we either find the target, but if we don't find the target, we know we're at least going to eliminate half of the possibilities. So we would eliminate this down to 8. Now we're only looking at 8 values. We still don't find the result. We keep dividing it by 2. We make it 2 remaining, and then finally, there would only be 1 value remaining. And either that's going to be the target or it's not going to be the target. And then we're pretty much done with the algorithm anyway. So the question is, if we have a while loop, the while loop is going to run as many times as we can divide the length of the input array by 2. How many times can we divide it by 2? Well, if you remember from your math class, that is a math equation called left to search, we did not find. So at this point, we're just going to repeat the algorithm, repeat what I pretty much just did. Now, if we take these two, add them together, divide by 2, the middle is going to be over here. So then we're going to check, is this equal to the target that we're looking for? In this case, yes, it is. So now we can return the index because that's what we were trying to do. We can return m, whatever it happened to be. I think it's 4 in this case. So that is pretty much the idea of binary search. Okay, so now the time complexity. If you know binary search, you already know that it runs in log n time, but let's quickly understand why. So we're not considering this example anymore, but suppose we had 16 values in the input array. Every time we go to the midway point, we either find the target, but if we don't find the target, we know we're at least going to eliminate half of the possibilities. So we would eliminate this down to 8. Now we're only looking at 8 values. We still don't find the result. We keep dividing it by 2. We make it 2 remaining, and then finally there would only be 1 value remaining. And either that's going to be the target or it's not going to be the target, and then we're pretty much done with the algorithm anyway. So the question is, if we have a while loop, the while loop is going to run as many times as we can divide the length of the input array by 2. How many times can we divide it by 2? Well, if you remember from your math class, that is a math equation called log base 2 of n. This evaluates to how many times can we divide n by 2. And suppose it evaluates to be x. That's equivalent to saying that 2 to the power of x is going to be equal to n. Okay, but this is too much math. Maybe you don't even care, but that's pretty much the idea. That's why our loop is going to run x times, which is going to be equal to log n. So it's not a big O of n algorithm. It's a log base 2n algorithm, which is much, much more efficient. Okay, so now let's code it up. And like I did in the drawing, initially we're considering the entire input array as our search area. So our left pointer is going to be at 0, our right pointer is going to be at the last index, which is just the length of the array minus 1. Now we want to continue going until there's no more possibilities left or we have maybe found the result. So the way to do that is to basically say that while our left pointer is less than or equal to our right pointer. Because I didn't show it in the drawing picture, but suppose we just had a very small input array just to illustrate the example. Our left and right pointers would both point here. Our mid pointer would
Scored. Okay.
also point here. But suppose our target is actually equal to 2. Okay, we'd say, okay, this is too small for our target. So we're going to set our left pointer to be equal to mid plus 1. So that means our left pointer would be 1 and our right pointer would be 0. That basically means our left pointer has crossed our right pointer, and that's how you know that we have no more values left to search. We did not find the result. So that's why we're doing less than or equal. If they're both equal, though, if they're both pointing at this value, that means we haven't looked at this value yet. So that's the idea. So each iteration of the loop, we're just going to find the midway point, which we can get by taking L plus R and dividing by 2. If the value that this index is at is greater than the target, then we want to look at all values to the left of it. So we're going to take our right pointer and set it to m minus 1. We want to look at all values to the left. We're basically shrinking our criteria. And in the other case, else if that num is smaller than our target, then we're going to do the opposite. We're going to set left equal to mid plus 1, just like in the drawing explanation. The last case is if neither of those are true, that must mean that we found the target. If it's not greater and not smaller, that means it must be equal. That means we can return m, which is the result. But if we went through every iteration of the loop and we didn't find the result, then outside of it, we are told that we should return -1 to indicate we did not find a result. So that's the solution. Let's run it to make sure that it works. And as you can see on the left, yes, it does, and it's very efficient. There's one more thing, though, that I want to mention to you, which probably won't come up in your interview. To be honest, it's never come up in mine. But there's actually one little bug here. I mean, technically, the bug doesn't exist in Python because Python integers are unbounded. They can pretty much be infinitely large. But in most languages like Java and C++, you might encounter an overflow. Because suppose we had a very large input array and then these two integers were very close to the 32-bit integer max, which is something like 2 to the power of 31, suppose they were both close to that, then adding them together would possibly overflow, and then we would get the wrong result in this value. So possibly your interviewer might ask you something about that, and how would you go about fixing that? Well, there's actually a way to do that. We can still calculate the midway point between left and right without adding them together, because we can take the distance between them. We can get the distance between them by taking right minus left and then dividing that by 2. Right, that will give us half of the distance between them. And we can take that and add it to the left index, because if this is halfway of the distance between them, and then this is the left index, by adding these together, we are getting the midway point. This is just a way to do the exact same calculation, but this way it will never overflow because right is always going to be greater than or equal to left. And in this case, we're not adding them together, we're subtracting them. So this will always be positive or it will be 0. So I'll run it and it does work pretty much exactly the same as you can see on the left, but this is just something I think a lot of people don't